Hi, it's time for the math. Easy. So we're going to discuss some more economics. Look at an example on the marginal cost versus average cost video, which I showed before in my previous video. So basically, let's make sure you watch it. But let's start the example here. The example: a company estimates the cost in dollars of producing X items is this one here. Capital C of X equals 2600 plus 2x plus 0.001x squared here. Then this is remember the cost function here, cost per produce X items. So now let's look at question A. Find the cost, the average cost, and marginal cost of producing 1,000 items, 2,000 items, and 3,000 items here. First thing we got to do, let's just make a table here. Okay, so here's a table I quickly made. Basically, X here is this column, the X items, 1,000, 2,000, 3,000, and now you have this C of X's is the cost. This is one's above here, and this is the average cost here, just small c of x. And marginal cost, remember, is just the derivative of the total cost here, the cost function. You can see my other video on more into it. But now if we to get the formulas for these two right now, because we know that number average cost is just equals to the total cost divided by the amount of items you produce, so x. And this is just the average cost here in this one. If you plug it in here, we're going to get a 2600 divided by x plus 2, because we're dividing it out now, plus 0.001x. So we have this one right here, and now if we get the derivative of the cost function is marginal cost, well, we just take derivative of this one. It's going to be 0 plus 2. Then using power rules, it's going to be 2 plus, well, 0.002x. So this is the marginal cost. And now if we just plug into the calculator there, let's just start with the cost function here. It's 2600 plus, this is going to be 2 times, well, 1000 here, plus 0.01 times 1000 squared. I already did that above, that's what it shows. Then you plug it in, you get it 5600 here. So 5600. And if you keep doing it and putting a calculator for all of these or using Excel, you're gonna get something like this here. As you see here, as you increase production, the total cost increases, and then the average cost here, you see it decreases here to 2000 here, but then it goes back up here at this 5.3, 5.87. So the reason for this one here, because as you can see, the marginal cost is increasing here, except at this point, this is less than the 5.6. So, or yeah, this is less than 5.6 average cost. So if it's less than average cost, then if you increased, or you bought more stuff, even though this marginal cost increased here, but this was a bit later here, it's gonna go, the average cost is gonna decrease here, because if you buy more things, remember this is the derivative or cost to produce one more item, and if one more item is cheaper than what you currently have average, then it's gonna lower the average price, and then it goes back up because this is higher than this. So if you keep reducing, it'll go higher. So that's and you can see more in depth on this in my video on marginal cost versus average cost video, and it'll also show you why the minimum is going to be somewhere in between here, where marginal cost equals average cost. And that brings us to part B. At what production level will the average cost be lowest, and what is this maximum average cost? And that is basically when marginal cost equals average cost, we get a minimum average cost. And then to get the production level, this is basically how many items to produce, that's X. And you see my video on how I proved this, but basically we just set them equal to each other and solve for X here. So marginal cost, remember this just equals 2, well, from the above equation, 2 plus 0.002x, and we set it equal to average cost, which equals 226. 100 divided by x plus 2 plus 0.001x here. So now we just simplify this one here, minus 2 by both sides, so we cancel the 2, and then we could just simplify this one, minus 0.001x. Also do it to this side, minus 0.00, this is going to be a 1x here. We're going to get, this is going to be 0.001x equals 2600 over x here, times x on both sides, just so we can get the x, get rid of this x, and then we're going to get a 0.001x squared equals to 2600. Simplify this one, we're going to get x is equal to plus or minus square root 2600 divided by 0.001 here. Remember, we can't have negative items because it's real life. We actually need positive stuff. So this is going to be a plus, and it's going to be equal to, well, let's just plug that in here. So we're going to get square root 2600 divided by 0.01. And this is roughly 1612.45. Let's just round it down to 1612. So this is 1612, or roughly. Just put this means roughly here. So now this should be the minimum production. This should be the production level to get a minimum cost here. And you could easily prove this by how the equation of cost is in this case. Well, let's just look at this equation of cost, and we're gonna get, we're gonna get the second derivative of the cost function. I mean, of the average cost function. But this is, let's just write this as minimum, or the x at minimum average cost. You see the proof in my previous video, marginal cost for average cost. But you could also see that if you look at the average cost function, if you take the derivative of it, we're gonna get, in this case here, negative 2600 divided by x squared. This is going to be a plus 0.001 here. And if you take the second derivative again, so now we take the second derivative, we're going to just get, this one's going to be a negative 2600 divided by x cubed. This goes to 0. We're going to get 5200. This is going to be plus x cubed. And this is always greater than 0. If it's always greater than 0, this is going to be concaving up in this entire, so in the entire domain here, it's going to be concaving up here. So if it's concaving up in this case, so we're going to have something like this. And this is where the x 1612 lies. And this is actually the absolute minimum here. So this has to be absolute minimum. And to answer the second part of the question, what is the average cost at the production level, which causes that minimum average cost? And that's just C of 1612, and this just equals to 2600 divided by 1612 plus 2 plus 0.001 1612. And then plug this in the calculator, we're going to get, well, let's just type it in here, 2600 divided by 1612 plus 2 plus 0.01 times 1612. And this is around 5.22 here. So this is roughly 5.22. Remember, it's per item, it's average cost. So this is the minimum average cost here, and this, remember, this also equals to C prime of 1612, or the derivative of the cost function, or marginal cost here. So this should be equal to it, and you can see from the table here, if you scroll back to here, so number 5.22 lies somewhere between here, and this would, and this 4 in here lies somewhere between the 5.22, which is marginal cost. So it should be roughly somewhere between these two here, and this is going to be, so you're going to, and this is also going to be 1612 here. So the minimum is going to be in between here. As you can see, it's getting smaller here and goes back up. So it should be somewhere in between there, and it is actually. And now if you were to graph the average cost and the marginal cost, this is going to be just plus 1 times x. This is the average cost there. This is going to be 2 plus, now we're going to graph the marginal cost. So we're going to get this one here. So if we keep scrolling down here, let's just scroll the vertical one so we get somewhere near the 5s. Okay, keep scrolling down here, so zoom back up. Okay, so this is a good scale here. As you can see roughly here, this is around 1612 for x, and y is 5.22. So as you can see, this is the red one is the marginal cost line, and this is the average cost line. As you can see at 5.22, if you go right of it, it's going to be increased 5.3. If you look up here, so 5.3. And if you go up past here, again, it's a 5.22. And then it keeps going back up, so 5.4. So as you can see, this crosses at the average. The average cost, or the marginal cost, crosses the average cost. When it's equal, then that's the absolute minimum of average cost here. So, and you can see it graphically there. Well, that's all for today. Hopefully you learned from this useful example. And remember, you could download these notes, and also just watch the previous video on average cost, marginal cost. See the proof of why this is true, why this is the minimum when they equal each other. Well, that's all for today. Remember, you download these notes, Dropbox link below, and stay tuned for another math easy solution.